Okay, vector and parametric form of a vertical line. And actually, this question in the end asks us to put this in Cartesian form. Okay. If you guys remember, Cartesian form was that form we just learned, that little equation where we had ax plus by plus c is equal to 0. Okay. But right now we're in our vector form, and we got to try to make sense of what this is, what type of line this is. So we're going to draw. There we go. We're going to draw a little grid here. And they've given us our directional vector. Now, a directional vector is at points 0 and 2. So let's just say this is how high 2 goes. Okay? So, what kind of vector or line would you say we have here? This is our directional vector. The slope of it is directly vertical. Okay? Does anyone know how to make a slope of a vertical line? We don't have one. It's infinite, this number. Okay? So, what we're going to do is we have point 1, 4. So if this is 0 and this is 1, let's say, call this 4. This is at point 1, 4. So if we're representing this vector, we have a line that is vertical heading upwards. Okay? So we have a vertical line here. And one of the things we're going to try to do is we're going to try to put this in parametric form so then we can relate it to the normal. If you guys remember, we want to find the normal to put this in Cartesian form. Because Cartesian form, the normal vector, which is point A and B, the uppercase, those are exactly what we're going to put in for numbers here. Okay, this is our A, and this is our B. That's what those equations were that we started out with. So, it's actually relatively straightforward to what a perpendicular to this would be in terms of finding it. But we could actually try to go through the entire process of finding out what perpendicular to this would be. If we have a vertical line, okay, and we have a point here, now the slope in this vertical line, our rise over our run, okay, we go up to, let's say, so say we start at 0 in our vector form, and we went up 2. So our rise would be 2. How much have we gone in terms of our run, left to right? Have we gone anywhere? 0. Can I divide the number 2 by 0? No. This is an undefined number. Okay? So we're not really going to have a slope for this. The way they'll represent it is it's a line that is just x is equal to. And x is equal to whatever the x-intercept is. So in this case, our x-intercept is what number? Anyone know? Right here. What would our x-intercept be?
1.
Just 1. Okay. So our x-intercept is the number 1 here. So our normal, we want it to kind of cross to this point, and it's going to have an opposite slope of that. Well, our normal slope is, if it was a negative reciprocal of this, remember we talked about taking slopes of a line, we can just flip them and make it the negative reciprocal. Well, what will the negative reciprocal of this be? Just 0. Okay? And again, because it's 0, it doesn't give us what we're used to seeing in terms of slope. We don't have a set number, one number over the other. So this perpendicular line, we'll do it in red, is going to go right across here. It's going to be the x-axis. But we're going to represent it with the letter y. And in this case, y would be equal to what? 0. Right? Because at the number 0, no matter what we plug in, our y value is always going to be 0. It doesn't matter what we plug into our x value. Okay? So I want you guys to think of the normal crossing this point, right? It goes from the origin to that point 0, 1. This is important here. So our normal point is at x value of 1 and a y value of 0. Okay? And we know the directional vector, well, there really is nothing to it. It is 0. So if we're going to put this in Cartesian form, if that's our A and our B, our AX plus BY plus C equals 0, okay? Well, my A being the X value and the Y value, so A being X, well, that just gives me 1X. My B value is 0, so it gives me 0Y, which is going to cancel it out, plus C in this case, okay? We're going to get X plus whatever our C value would be. Now, our C value is a number we try to solve for. But because no matter what happens here, what is our X value going to be as we go up and down this line? It's always going to be 1, okay? So that's essentially going to be our C value. Our C value is going to be our number 1 or negative 1. So our X, like we talked about before, will be 1. Now I know we already got to that answer as we kind of had here. And this is a confusing way to do it because we're talking about a vertical and horizontal lines. But as we go into the Cartesian form with non-vertical or horizontal lines, it's going to make a little more sense in terms of finding the slope and putting it into a normal, okay? So we had to think through that one first before we went anywhere.